So the next problem that we are going to be tackling is very similar to the previous one. However, in this case, we are doing the opposite. So the question asks, what is the frequency of violet light with a wavelength of 408 nanometers? In this scenario, they're giving us wavelength, and they're asking us to determine frequency. So we're going to tackle this problem in the similar manner as we just did. We're going to be using the same formula that relates wavelength and frequency together. And we're going to be manipulating this equation in order to solve for our frequency. So we know what our speed of light constant is. We know what our wavelength is, 408 nanometers, and what we are looking for is our frequency. So we're going to manipulate this equation again. But in this case, we are solving for frequency, so we divide each side by wavelength. And so we now have the equation, frequency is equal to the speed of light divided by wavelength. A few things to also take note of is, in this case, our units do not match one another. When we're solving these problems, we have to make sure our units can cancel. So we're going to have to convert 408 nanometers to meters. We know that nano is 10 to the negative ninth, so 408 times 10 to the negative ninth meters. So it's important to remember that 1 nanometer is equal to 10 to the negative ninth meter. That's a very important concept that you have to know, and you have to know a lot of these prefixes. So once we have everything in the appropriate units, we can then continue on to the next portion of this problem. We plug in the 3.00 times 10 to the 8th meters per second. We divide it by the wavelength that they give us, so 408 times 10 to the minus 9th meter. Our meter and meter cancels out. We'll be left with seconds. And we end up calculating it to be 7.35 times 10 to the times 10 to the 14th per second. It's important to note that our units are correct because frequency has units of 1/seconds. And once that's done, you can always double check your answer by plugging it back into the equation, and you can multiply your wavelength times your frequency and make sure you can get your constant. So that's one way to double check your answers.